In the last lesson, we studied about bitwise operators. Actually, I took a deep dive into studying in bitwise operators. Sorry. The reason I went ahead into great detail for bitwise operators is actually very straightforward, because bitwise operators are one of the operators which you wouldn't have studied in mathematics before. And the other reason is this is an operator which is a bit tricky because it operates on bit levels, that means zeros and ones, and it is one of those operators which will make your job very easy, but at the same time it takes a bit of time to actually get what bitwise operators actually does. Okay, so this lesson I'm going to look at all other operators combined, because most of these operators, right, we are either going to study in the next lessons, or you would have already studied. Okay, so for example, as I already told, this operator, these operators we're going to study in the next coming lessons. Okay, and this table actually lists all the operators in the order of precedence. These the ones listed at the top have the highest precedence, and the ones listed at the bottom have the lowest precedence. And operators which are on the same row have the same precedence. Okay, so for example, this operator is a function call operator, and this operator is an array to get the element in an array, and this is a pointer indirection operator, and this is to access the member of a structure. So these operators we've not at all studied. Okay, and few of the things I would like to mention. See, these operators, right, star, division, percentage, plus, minus, less than, equal to, greater than, equal to, not equal to. These are operators you would have already gone through. Okay, few of the operators which you have not gone through, I will go through examples. Okay, so for first of those operators is the increment operator. Okay, so let's have a look at that. Okay, so you have this increment operator and the decrement operator. What this basically does is it increments a variable by 1. It can be operated only upon variables, and it can be operated only upon type int. That means char, short, int, long, unsigned. These it cannot be operated upon double. Okay, so first let me have a look at the increment operator. What it basically does is it increments the variable by 1, this increment operator, and this decrement operator decrements a variable by 1. Okay, so there are basically two forms of it. One is the post increment, that is this. That is the first of the expressions. What it really means is it will assign the value of I to a, and then it will increment the variable I. That means, let's say if I is 2, okay, now the value of a will be 2, okay, but the value of I will be 3. For example, if you again do it pre-increment, that is plus I, what will happen is the value of a will be 3 and value of I will also be 3. I hope you get it. So let me just explain it in terms of decrement operator as well. So let's say you want to assign I to a. Okay, now I, let's say, is 4. Okay, and now it's a pre-decrement operator. So what happens is, first the value of I gets decremented. That means 4 is to 3, and then 3 gets assigned to a. But if we had used it in terms of post decrement, that means I minus, what would have happened is the value of I will be assigned to a. That means 4 will be assigned to a, and I will be reduced to 3 afterwards. Okay, so that's the difference between pre-increment and post-increment. So we'll be using it, and I'll be explaining it again when we use it in our programs. So, but let me go to the next operator. Okay, so the next operator is the assignment operator. See, when you say a equal to a plus 2, do you observe that a is common here? You can also write it as a plus equal to 2. So the same is with all the operators. A minus equal to 2, a star equal to 2, a percentage equal to 2, and the same is with bitwise operators that we introduced last lesson. you could use a light shift 1 equal to 1. So okay, let me repeat it. A right shift equal to 1. That means a will be right shifted and it will be assigned to a itself. Okay, so that's the difference. And let me look at the another operator. This is called as the conditional operator. Okay, what basically does is it is nothing but an if else expression. So if you it's like this: if a greater than b, you say max of a underscore b equal to a, else uh, else max of a underscore b equal to b. So that is actually represented in this. So as you see this variable, right? So first thing, this conditional expression will get evaluated. Then if it is true, whatever is here, that means the left side of the colon, right, gets evaluated. If it is false, right, the right side of the semicolon of the colon gets evaluated. So basically it's an if else expression that we are trying to evaluate. Okay, so okay, afterwards I'm going to talk about some things that you need to keep in mind. Okay, for example, let's say you have this kind of an expression: result res1 equal to x1 is a function call plus x2 is a function call. Now the C programming language does not guarantee whether x1 will get executed first or x2 will get executed first. It is compiler dependent. We can have x1 executed first or x2 gets executed first. What C guarantees is that both will get executed and then the result will get added and assigned to res1. So when you have write programs like this or expressions like this, we need to make sure that the order of execution will not change the result. For example, if x1 it gets executed and it changes a variable, and x2 should not use the same variable, something like that. Okay, there's an exception to it. Okay, what it really means is the order of execution is not guaranteed for all operations except ampersand, and that means the binary and the conditional or and the conditional and. Okay, here the order of execution is guaranteed and it happens from left to right. Okay, from here to here, and it will stop as soon as the truth or the falsehood of the expression is established. That means if a, the function called a, returns false, then none of the b and c will be called. Let's say if a returns true, then only b will be called. But if b returns false, right, then c won't be called. If a and b both return true, then only c will be called. So this is a fact you could use in many of your programs, and I will at a future point show you in certain programs of how this works. Okay, the next thing I want to stress upon is, for example, if you have a function call, okay, if you in C, the arguments are n plus plus comma is n. Okay, here you're not guaranteed which of the arguments will get evaluated first. N plus plus may get evaluated first, or a of n can be evaluated first. So depending on the order of execution, you understand that the kind of arguments that gets passed to the function is different. So C does not guarantee which of this gets executed first. So it's better to avoid these sort of confusing expressions in your programs. Last, okay, you have this kind of an expression. It's the most dangerous kind of expression. This thing, again, C does not guarantee what will happen, so it's better to avoid. It again depends on compiler. So anything that depends on the compiler for its execution, right, it's always better to avoid it. Okay, so with this I'm done with the lessons of precedence and association of operators. In the next lesson, I'm going to talk about something different. Okay, just before I leave you, right, just one thing, I'm going to leave you with a question to think about. Okay, so I need you to write a program which prints hello world, nothing else. There's only a catch: you cannot use a semicolon inside the program anywhere. In that file you don't have a semicolon. Okay, without a semicolon you need to print hello world. Okay, I'm going to leave you with this question. Okay, best of luck. Okay.